Here is a laundry list of commands that we can utilize to configure NTP. The first command listed is NTP master. Now I want you to be very careful with this command because the definition does not describe it perfectly. The definition here says configures the device as an NTP server. What this really means is it's going to configure this device as the authoritative time source, meaning that it is the time source. Does it make sense to set up your router as the authentic time source? Well, where is it getting its time from? Think about that. Where is it getting its time from? Do you have the ability to attach an atomic clock to your router? No. Do you have the ability to attach an external clock to your router? No. So the time for the router is coming from its internal clock. And that internal clock can drift over time. So it's not really a highly accurate time source, is it? But if for some reason you don't have the ability to set up this device to connect to that authentic, highly accurate external time source, then this would be your only option for your environment. So picture your environment without internet connectivity. It's really hard to do that, isn't it? But without internet connectivity, do you have the ability to connect to an authentic external time source? No, you don't. So you could set up the NTP master inside your organization, and then that NTP master could be that starting point for time, but you would be relying on that internal clock to give out time. So what would we do? Well, if we have internet connectivity, it's better for us to set up a device, whether it's a router or a specific server that's going to be our NTP server. We want to set those devices up to point to that server, and this is the command we do. NTP server on our router 10.1.1.97 says you are the client of the server at this IP address. So for example, that would be the IP address of the NTP server out on the internet. That is highly accurate. Now, does that prevent this router from being an NTP server for other clients? No, not at all. What you would do is you'd go to another device. Let's say you have a multi-layer switch in your organization or another router. And what you could do on those devices is type in NTP server, and then the IP address would be the IP address of this specific router we're talking about right now. So you're just pointing through that hierarchy. So our router would be a stratum level of 2 from the stratum level 1 authentic time source, and then the other devices in our organization would be stratum level 3 or 4 or 5, depending on how we've implemented the hierarchy. Now, the peering command can be utilized for the redundancy that we might need at certain points within the environment. So, for example, we have a router set up to get its time from a particular time source, and then it's going to hand out time to the rest of the devices in our organization. We have another router that's doing the same thing. Well, what if they lose connectivity to their time source? Well, what they can do is they can now help each other out, meaning that if this router still has connectivity to its time source, then it can get its time from that device and still be able to service the clients behind it. So it's about ensuring that we maintain a peering relationship with other routers in our environment that have time as well, so if something happens to our authentic time source, we can still service the clients behind us. These two commands are rather interesting here. The NTP broadcast command and the NTP broadcast client. What do they do for us? Well, the NTP broadcast command is designed for us to send out NTP packets as broadcasts to the local area network. So we do this command on a specific interface. For example, the interface, the SVI on a multi-layer switch, or on our router, the specific interface going down to the end stations. And what we'll do is we simply just broadcast the NTP packet. So instead of having the clients configured to ask an NTP server for time, we are simply just sending that NTP broadcast out to all the devices out that interface. And we want them to do what? We want them to synchronize. We also need this command right here on the client's, the other end. So if we expect a device to synchronize its time using the NTP broadcast, then we need to use the NTP broadcast client command. And then that specific client would then be waiting, and it would receive those NTP broadcast packets and then synchronize its time. So this would be the command that we'd use on a router if we are expecting a router to synchronize its time using NTP broadcasts. On a Windows box, Linux box, it'd be slightly different commands based on the implementation of this feature on those devices. But this broadcast feature is really good for the end stations in the organization. We can simply set up our environment so that way there we can send the broadcasts out those interfaces down the local area network, and then our clients will be able to synchronize their time with this particular time server.